These programs are distributed under a Creative Commons Attribution, Non-Commercial, No Derivatives license. You may copy and distribute these programs free of charge. You may not sell them, and you may not alter them. These programs are part of a study examining the value of podcasting as a medium for medical education. If this is the first time you are viewing a program in this optics series, send an email to jyoungmd@gmail.com with your name, position, institution, and city, state, or province and country. Thanks, and enjoy the podcasts. Today's discussion is about astigmatism types, and it is valuable to know the astigmatism types when someone asks you. It's valuable to know the astigmatism types when you're writing a consultation letter to a non-ophthalmologist. Otherwise, it's not all that useful. We are going to look at our same series of slides here. I only have very few slides, but we're going to look at them 3 times. This is a myopic patient, and he's a -5 myope, just sphere. DS in this case stands for diopter sphere, indicating that there's no cylinder here. And we see that the image focuses in the vitreous, and if we were to draw out the total power cross, as is done in the lower left-hand corner of this slide over here, we see that it is -5 and -5, and anywhere you slice it, it's -5 because it's a sphere. This is a patient with simple myopic astigmatism. Simple in these cases means that one of the focal lines is on the retina. Is that simple? I don't know, but that's what it's called. In this case, if we were to section this eye vertically, if we were to section this eye sagittally, then the picture that we would see would be the dashed teal-colored lines in this diagram. And you see that they come to a point on the retina. If we were to section this eye axially, then we would see the red lines drawn on this diagram, which come into focus in the vitreous. So one of the focal lines is on the retina, one of the focal lines is in the vitreous. We refer to this as simple myopic astigmatism. And I've given the example prescription in the lower right-hand corner, the manifest of -5 + 5x is 180. This is a patient with compound myopic astigmatism, and in this case, both of the focal lines are in the vitreous. And the prescription I've given as the example here is -5 + 2x is 180. This is a patient with simple hyperopic astigmatism, and you'll remember that I said that simple means that one of the focal lines is on the retina. So in this case, if we were to section this eye axially, it would look like a myopic eye. It would look like an emmetropic eye with the image coming into focus on the retina, but if we were to section it sagittally, it would look like a plain old hyperopic eye with the image being focused in back of the retina. At any rate, one focal line on the retina, one focal line in back of the retina equals simple hyperopic astigmatism. Compound hyperopic astigmatism means that both of the focal lines are in back of the retina, and mixed type, as you would guess, means that one focal line is in front of the retina and one focal line is in back of the retina. So that was lap 1 through these slides. Let's do lap 2. For lap 2, what we're going to do is we're going to look at the total power cross that is indicated in the lower left-hand corner of this slide. And I've taken the manifest, the -5 + 5x is 180. I've generated a total power cross with it, and the total power cross looks like this. It has 0 for its power vertically and -5 for its power horizontally. And you'll remember when we did the image on the retina of a patient with astigmatism not wearing spectacles, if we were to plot this out, he has 0 units of blur vertically, 5 units of blur horizontally. This would plot out to the horizontal focal line. And you can see that too if you look just at the values of the total power cross. One of them has a value of 0. That tells you that one of the focal lines is on the retina. This is compound myopic astigmatism. We look at the total power cross, and we see the value of the total power cross is -3 vertically, -5 horizontally. They are both going to come into focus in the vitreous. And again, you could plot it out and see that the image on the retina would be an oval with its long axis horizontally. But that's not the question that I'm asking here. I'm asking what sort of astigmatism type does this patient have? It's compound myopic astigmatism, and it is that because of the arms of the total power cross. One of them is -3, one of them is -5. They're both minus. They're both in the vitreous. This is simple hyperopic, and we look at the total power cross. One arm is +8, one arm is 0. 0 means that one of the focal lines sits on the retina. +8, you know that the other one is in back. Compound hyperopic, both of them are +8 and +3 for the total power cross. And for the mixed type, one of the arms of the total power cross is hyperopic, one of the arms of the total power cross is myopic. You can see that one would be in the vitreous and one would be in back of the retina, and that's mixed type. Okay, this is our last lap through these slides, and this is the simplest and most useful lap. What is it that determines where the focal lines are looking at the total power cross? Well, we know one of them is 0 and the other one's -5. So one of them is on the retina and one of them is in the vitreous. But would it have mattered if the -5 were -3 or -1 or -7? No. The only thing that matters is that it's minus. So what we need to know to determine the astigmatism type is what the signs are, just the signs, of the two arms of the total power cross. And how do we get the values of the two arms of the total power cross? One arm is the sphere, and the other arm is the sphere plus the cylinder, right? Not sphere plus half of the cylinder. Sphere plus the cylinder. By the way, what is sphere plus half of the cylinder? That is the spherical equivalent. And why is it that? It is that because that's the average of the two arms of the total power cross. But we're not interested in the average. We're interested in what the signs are of the two arms of the total power cross. So if we look at the manifest in the lower right-hand corner, we see +5, -5 axis, whatever. One of the arms has to be -5 because that's the sphere. The other arm is the sphere plus the cylinder, which is 0. So if one arm is minus and one arm is 0, that means simple myopic astigmatism, because 0 means that one of the focal lines is on the retina, and minus means that the other one's in the vitreous. That's the definition of simple myopic astigmatism. If we look at the prescription in the lower right-hand corner, -5 + 2 axis something, -5 is one of the arms. The other arm must be -3, right? That's -5 + 2. So one arm of the total power cross is minus. The other arm of the total power cross is minus. Therefore, it is compound myopic astigmatism. Similarly, with simple hyperopic, one arm of the total power cross is 0. The other arm is +8. Is plus. One arm is 0, one arm is plus, therefore it's simple hyperopic. They're both plus here, therefore it's compound hyperopic. And one of the arms of the total power cross is plus and the other arm is minus. Therefore, this is mixed type astigmatism. So all that you have to know is what the signs are of the two arms of the total power cross. Keep in mind, one of the arms is the sphere, the other arm is the sphere plus the cylinder, and you'll immediately know the astigmatism type.